So we just took a quick overview of what's inside an XNAT. I think it'd be a good idea for us to take a deeper dive into the components of XNAT and find out what it is that makes it work. This is going to be important to you for performing your administrative duties, and this might be a lecture that you want to come back to multiple times during this course. Let's take a look. Here's a full diagram of the major components of XNAT. It's a bit overwhelming like this, but don't worry. We're going to take you through it step by step. At its core, XNAT is a Java web application that is installed as a WAR file. It runs on an Apache Tomcat server using the Turbine framework. For the most stable performance, we recommend installing XNAT on a Linux file system or on a virtual machine. Users access XNAT via a web browser at a URL of your choice. User authentication is handled via Spring Security. XNAT includes an Nginx proxy server, which can be set up as needed. Your IT ops team may have additional network access restrictions to enforce, depending on your environment. All user data is stored in Postgres, alongside your indexed project data, and XNAT also uses Hibernate to store system preferences. Data types are defined in XML schema docs and can be installed via plugins. The XNAT front end uses velocity templates to serve data into HTML structures. A number of JavaScript libraries are required to render the front end. XNAT is not functional if JavaScript is disabled on a user's browser. Most actions for creating, viewing, modifying, or deleting data are performed by calls to the XNAT API. The XNAT API is defined in a series of Java classes and can be extended by plugin developers. XNAT has a built-in DICOM SCP receiver that can be configured to receive image sessions sent from PACS and other DICOM application entities. All incoming image sessions are run through a configurable anonymization process before they are archived in a project. XNAT reserves 3 spaces in your server's file system for storing files: a cache space, a pre-archive, and an archive. The pre-archive is a dedicated file system for temporarily storing DICOM image files, whereas the archive is dedicated for long-term storage of all resource files. We recommend that if you're setting up backups for your file system, that you only back up your archive. For data processing, you can use the XNAT pipeline engine to run processing pipelines, or install the container service plugin and run processes on containers in custom images. Either of these processing methods can be configured to connect to external computing clusters. XNAT process steps are recorded internally as workflow events, and XNAT has an event handling service that is built to key off of discrete events, such as scan created or resource updated, with filtering enabled to only act on certain events. XNAT also allows plugins such as the container service to add automated actions that can be performed based on those events. Other applications can interact with XNAT via the API, as long as they have a valid login or user alias token. For example, we recently introduced a paired desktop application called the XNAT Desktop Client, which can handle large downloads and can upload image sessions in bulk with client-side anonymization. Next, we'll walk through the steps of setting up your XNAT for the first time.